work. So I'll come back to this theme, but in societies, we develop things like insurance agreements. The Tylers made their fame and fortune in the Farmers Insurance Group. Insurance is a way that we band together to deal with risk and uncertainty, and in a way we create public goods and common pool resources. So I've been working on a number of problems of this sort, of insurance agreements, with Avinash Dixit, a distinguished economist at Princeton, and Dan Rubenstein, a colleague in my department, actually my chairman in ecology. Dan works on herdsmen in East Africa who share grazing grounds. The idea being, if I'm having a bad year in terms of climate, I don't have a place to graze my cattle, I want to send them to, and ask you if you will accept them, and you say, why should I do that? And I say, well, next year the situation may be reversed, you can send yours to me. And so that's the essence of a cooperative insurance arrangement, and we investigate the conditions under which this will work, and if it won't, are there so-called second best solutions that will work in a game theoretic sense. We have lots of examples, and there have been lots of studies shown that individuals will pay a price themselves to punish others who don't follow the rules of the game, if their sense of fairness has been violated. Ernst Fair, aptly named, has done numerous studies, many other people, showing that individuals will pay a price to punish others who don't contribute to the public good. One game that's been much studied by economists and other social scientists is called the ultimatum game. I give Maya here $100,000, and which I may do, which she has to share with someone in the back whom she doesn't know, and you, Amber, okay. Well, she knows you, Amber, and she will only play this game once. And what Maya has to do is to offer Amber a share of the $100,000, whatever share she wants to give her. She can offer her half or $1 or whatever, and then Amber has to decide whether to accept. If Amber accepts, everything's fine, but if Amber turns it down, neither one of them gets anything. So the question is, how much should Maya offer? And I play this game in my class, and one student offers the other $30,000 in this situation, and she turned it down. And I said, by turning it down, you're turning down it's going to cost you $30,000. And she said, yeah, but it's going to cost him $70,000. So this is the principle. Most of us would not turn down $30,000, but most of us would probably turn down $3. It's worth it to us to punish that person who has violated a fairness norm. Even though there's no negotiation, we'll never play this game again. So this has been played in various cultures, and there are very different standards about what people offer and what people will accept. But across the cultures, people will pay a price to punish others who have violated some social norm, even though it doesn't make sense within the context of that particular interaction. It's somehow embedded in some broader framework. So these social norms are crucial to understanding how we get cooperation in society. With two former students, Alessandro Tavoni and Maya Schluter, I've been doing work which looks at fisheries withdrawal systems, water withdrawal systems, in which you have a cooperative norm, but individuals who withdraw more than the cooperative norm are punished. They're ostracized. And what we examine is under what conditions those sorts of arrangements are stable. How do you sustain these cooperative norms? How do they emerge? What's the role of pro-sociality in smaller groups, which is concern for other individuals? So these examples, I think, are of specific interest, but more broadly, they're models for how do we address international cooperation. Can we learn from what goes on in nature, cooperation, and the dynamics of collective phenomena like the birds that I showed you before about how people interact? Obviously, people are different, but what can we learn from it? Public goods problems are widespread. This is the sort of commons that I showed you before, and this is a picture that Carol took when we were in South Africa of a termite mound, which is a cooperative phenomenon, which produces a public good. So these are widespread. You heard in the introduction some discussion of nitrogen fixation. Nitrogen fixation is the way that plants, for example, convert nitrogen that can't be used into usable forms, generally through partnerships, for example, with bacteria or mycorrhizae. But nitrogen fixation is costly. You have to produce a nodule. You have to make an investment in it. And if I'm fixing nitrogen and you're right next to me and you're not paying the price of fixing nitrogen, you still gain from the nitrogen in the soil. So it introduces the potential for cheating. So this is a public goods problem, very similar to the ones we face in our societies. Tumors are a breakdown of the commons because the tumor itself is the profligate spread of and growth of some cells, ultimately at the expense of the organism they're part of. So it's a breakdown of, the organism is a public good in a sense. Indeed, this was the cover of Nature last week, which turns the problem around. Tumor cells produce certain compounds, cytokines and things, that are crucial to the development of the tumor. So if you could interfere with that level of cooperation, this might be actually a way to deal with cancer. And so working with David Dingley and George Pacheco, I've begun to look at these problems of how do you use this in reverse, perhaps to deal with the problem of cancer. Even bacteria cooperate. When you go to the dentist, it's because of the plaque on your teeth, which is a biofilm of many, many species of bacteria, which send signals to each other and exude extracellular polymers that create a matrix for growth. So all of these are examples of the production of public goods in nature. So what can we learn from nature? These are leafcutter ants engaging in some collective activity where they take the leaves to their common home. This bothered Charles Darwin. It was a puzzle for him. It delayed the publication of The Origin of Species for 20 years as he tried to understand, in particular, in the social insects, why females would give up their own fitness to help their sisters and under what conditions. And this remains an area of great debate. Darwin never really figured it out. J.B.S. Haldane reportedly said that he had the answer. He said, I would give up my life for two brothers. I would jump in the river, is what I think he said, for two brothers or for 8 cousins, making the calculation of the degree of genetic relatedness. W.D. Hamilton, who wrote his thesis on this topic, never really believed Haldane said that, but this is a different story. Hamilton focused especially on the social insects. In the social insects, the bees, the ants, the wasps, the males come from unfertilized eggs. So the system is called haplodiploid. That means that males come from unfertilized eggs, so the females who have the same father share 3/4 of their gene, making cooperation much easier. So genetic relatedness can help, although this has remained a very controversial area. And E.O. Wilson, who was a great supporter of this idea when it first came out, a previous winner of the Tyler Prize, has recently changed his mind. I don't want to enter that debate, but it's clear that close genetic relationship is not essential for cooperation. These oxpeckers on the back of this animal are helping to prune it and obviously gaining something from it. This is a cooperative arrangement. Individuals engage in reciprocal altruism, helping each other. We became interested in the role of leadership in these systems. This is work with Ian Cousin, my former postdoc, now colleague at Princeton. This we published in Nature in 2005. And what we did is we built a model. If I ever say I mean we here, okay. But if I say we, I probably mean Ian did it. And so in this, we have individual fish who have a certain direction. They're moving through the system, and they change their directionality at each point in time in relationship both to their own information and the information of what their neighbors are doing. So it's a trade-off between do I find information myself or do I steal it from my neighbors? It's a fundamental problem. It's related to the essential question of exploration versus exploitation as well. So in the first movie I'll show you, there are 100 fish. Only one of them has any idea where it wants to go. The other 99 are just sort of wandering around. They keep pulling that one back in. So the white dot on the front is the so-called informed individual. This blob goes nowhere. If I raise it up to 5, it moves haltingly here. And in this movie, there are 10 who want to go here. and the group moves rather quickly to it. So animal groups can be led by a very small number of individuals. These are groups of different sizes. And as you can see, by the time I get up to 5 or 10 individuals, the group moves about as fast as it can up to the goal. But not only animal groups, but human societies as well. We're being led by the lemmings off the cliff. We're led by a very small number of individuals who actually are making independent decisions. Think about it in terms of who's making the decisions for you and the degree to which we tend to follow others. What happens if not all the individuals want to go the same way? 5 want to go here, 5 want to go there. The group's either got to make a collective decision or split. So we've done a lot of work studying the conditions under which they will make a consensus decision. And we find that unopinionated individuals are crucial to the development of consensus here. And this is an active area of work for us. So my argument is that the greatest need for us is to understand how individuals make decisions and how collective decisions are made, which means we're going to have to build bridges from science and management to the social sciences in order to understand human decisions, and especially to the roles of leadership and of collective opinion. Ecological systems and socioeconomic systems alike are complex adaptive systems made up of individual agents with emergent properties that feed back. Adam Smith is often cited in the economics literature for talking about the invisible hand, the idea that economies left to their own will reach efficient equilibria. But as we learned in 2008, if we didn't know it before, the invisible hand doesn't protect society. We'll reach some equilibrium, but there's no reason to expect it'll be one we like. In environmental system, these lessons are magnified. People talk about Gaia, that systems will self-organize and reach equilibria. And that's probably true, but it's not it may be an equilibrium in which we are no longer partners. And so we can learn from the environmental systems for economic systems and vice versa. The complex adaptive system perspective, I think, means that in both cases, and we just, Ken Arrow and Paul Ehrlich and I just had a paper that came out a week ago in which we made these points. In both cases, management's going to require a balance between laissez-faire, free market, and regulation. Finding that balance is the trick. We're going to need, for environmental systems, new institutions, and they're going to have to be adaptive. My favorite example is the human immune system, which has evolved in response to the fact that we are predictably going to be faced with pathogens that attack our bodies, but not predictable which pathogens they're going to be. And so we need a system that has early warning signals, that has generalized responses that buy us time, and it has adaptive responses that learn and protect us the next time around. And whether we're dealing with bioterrorism or financial markets or environmental systems, we're going to need adaptive institutions. And how do we build up to deal with problems of climate change? Lynn Ostrom argued we need polycentric approaches, and we've been trying to build on that. I accept her arguments. That means you build local agreements, and these become modules, building blocks, for getting first the US and China, Western Europe, et cetera, building up. Trying to get 200 nations all at once to agree is probably hopeless. Can cooperation be extended to the global level? This is the G19 now. This is the great challenge facing us. Unfortunately, what we learned from natural systems is the emergence of cooperation within groups, of which we have multiple examples, is often for the benefit of conflict with other groups. And getting back to where I began, getting back to Pogo, in the global commons, there is no other. He says it's hard working on all this stuff, and Pogo says, yep, son, we have met the enemy, and he is us. And therefore, understanding how to achieve international cooperation, we're going to have to do like we did in the movie Independence Day. It's at the core of achieving stability and dealing with our common enemy, which is environmental degradation. We have to recognize it's not another culture, it's environmental degradation, so that we can achieve a sustainable future for our children and our grandchildren Thank you very much.